very warm welcome to Breakfast with Arup. It is great to have such a house full again. Fantastic to have your support as always. So, to our speaker, Richard Boyd was born in a small town in Northern Ireland and was represented in Parliament for most of his first 18 years by a member of the DUP, an experience that we're all going to gain an insight into. Despite this, his early years were largely insulated from the turbulence of Northern Irish politics. Engineering was a strong influence from the beginning, inspired by a close family friend, a railway enthusiast, a collector of antique clocks and vintage cars, as well as being a skilled machinist. Richard has many happy early memories of the smell of coal smoke or dripping oil wafting across from various examples of engineering history. His father comes from a small holding farming background, so being self-sufficient and doing more with less were values he was taught from an early age. Rainwater harvesting, organic farming, and energy efficiency, in the guise of being continuously scolded for leaving the lights on, were all practiced in the Boyd household long before they became commonplace elsewhere. These practices continue in the family home to this day. Richard duly reports that this year's asparagus crop was excellent and the strawberries are coming on really well. This background proved fertile ground for a growing interest in environmental issues. This was fostered further by a primary school teacher who pioneered Richard's primary school to participate in the Eco Schools initiative. This led to the creation of wildlife gardens in the grounds, and a sign of future senior management potential, Richard was tasked with diligently carrying out the daily turning of the tumbling composter. Richard's awareness of the challenges of urbanization in the developing world started during his secondary school, initially raising money for and then spending 4 weeks to help construct freshwater projects in southern Kenya. This trip to Kenya, age 16, had a profound impact on the budding young engineer, spurring an interest in development work that continues to this day. After spending a gap year in the exotic climes of South Gloucestershire, Richard studied engineering at Cambridge, initially intending to make a career in motorsport. It wasn't long, however, before his interest in the environment overcame this. It was something that entered into all aspects of his student life. He helped revive a college film society and exploited his position of selecting titles to watch and subjecting his peers to a succession of environment-themed productions, from Al Gore's Inconvenient Truth to Manufactured Landscapes, a film about the photography of Ed Badinsky. Richard now lives in South London in a shared flat, eating pulses, turning off the lights after his housemates, and still turning the Tenant and Resident Association's tumbling composter. He is too impatient to wait to buy a home of his own, so instead he's trying to build one. And if anyone has a small plot going within cycling distance of the West End, he'd be very interested to hear from you. I'm looking directly at Benji Lesser at this moment from Derwent. Richard's route through Arup has been varied, starting as a summer student in Birmingham, designing alignments for HS2, then as a graduate in London, joining the building structural engineering team in Arup Associates in 2011. This role has taken him to the deserts of northern India, to the Arab Emirates, and then on to the Slough trading estate. He now works with teams from across Arup in London and around the world on environmental impact of materials and the transition to a circular economy. So, without further ado, I am really very happy to introduce the very charming and lovely Richard Boyd. Thank you, everyone.
Thank you, Farah, for that introduction, and good morning, everyone. Now, I know what you're all thinking, and no, it's not as bad as you think. While I look young, I was not born in the 1990s. But yet, in discussions around the future of the industry, 2050 is an oft-cited, yet seemingly distant milestone for us all. And when 2050 comes around, I will still hopefully have a good decade of my career left to go. So in discussions around the future of the industry, it's clear that people in my generation must participate in, if not drive, these discussions. So what am I going to talk about today? This morning, I want to discuss the circular economy, specifically the value of a circular economy approach, and how we might make it a practical proposition in the built environment. In other words, I want to ask, what does this mean for all of us in this room and all of the industry as a whole? There's a growing buzz around circular economy in the built environment. As we speak, books are being written, events are being organized, a bit like this one, and time has been put into thinking about what it means. And as with any idea of the moment, the risk is this idea starts being viewed as a bit of a buzzword, a term with heavy negative connotations. In the built environment, we're very familiar with buzzwords. We know that they lose their meaning through overuse, and we know that their definitions are stretched to suit the purposes of people looking to be associated with the next big thing. The challenge, therefore, and even I've been around long enough to know this, is how do we turn this buzz and this talk into real action on real projects? So what I want to do today is anticipate this process of buzzwordification, to coin a buzzword. I want to share my view on what circular economy is, and to give some examples to help the term keep its shape and its meaning. And I'll suggest some questions we can all start asking on our projects today that will take us closer to making the circular economy in construction a reality. So why is the industry talking about circular economy? Well, to put it directly, is because it could be an enormous commercial opportunity. Work by McKinsey suggests that, by increasing resource productivity, circular economy could add 0.6 trillion euros to the EU economy by 2030. Throw in a few non-resource productivity and other externality benefits, and that number becomes 1.8 trillion euros. The big question is, how do we go about capturing that value? And perhaps more importantly, who is going to capture that value? Why am I talking about circular economy? Well, as Farah mentioned, I had a visionary and slightly eccentric primary school teacher, and this means that I've been aware of global warming and climate change since I was about 9. And as an engineering student, the challenge of developing a society that operates within planetary boundaries was framed as the defining challenge for my generation of engineers. This is why I've chosen the career I have done. And I see circular economy as central to the engineering response to global warming and climate change. I'm therefore pleased that global leaders have committed to keeping global temperature rise to below 2 degrees Celsius. But I know that this is only going to be possible if we change the way we use materials in the built environment. The production of just 2 materials, cement and steel for construction, contribute to over 10% of global CO2 emissions. To put that in context, global aviation accounts for only 2%. And alongside the commercial and carbon considerations, there are other reasons for adopting a circular economy. For example, the volatility that comes from relying on unstable parts of the world for our resources, increasing habitat destruction, and even the prospect of running out of some materials altogether. The challenge is tough if you look at it in the present day. If you look into the future, it gets harder. By 2050, it's predicted that the global urban population will increase by a further 2.5 billion people, up from 3.9 billion today, a 64% increase. The growth in the built environment required to accommodate these new inhabitants will drive significant growth in material consumption. Demand for steel is expected to double by 2050, while demand for cement is expected to go up by up to 76%. Most of this growth will take place in the developing world, particularly in China, India, and Nigeria. They will respond to this growth by building whole new cities and neighbourhoods. Here in London, we face a different challenge. London is facing accommodating an additional 2.4 million people by 2041, a 25% increase. and that's within a mature city served by low-performance legacy infrastructure. 87% of the buildings that will be still standing in London in 2050 have already been built. So it's clear that the ideas of the circular economy will also have to address the challenge of being able to do more with what we've already got. So having set the scene and answered the question why, I also want to ask the question, why are we talking about this now? To answer this question, it's time for a quick history of circular economy. It's time to take a closer look. The concepts behind circular economy can be traced back to the work of architect Walter R. Stahel and academic Genevieve Reday-Mulvey. In the late 1970s, leaders of French industry were concerned about the numbers of jobs being lost to automation. Sounds a little familiar. They, through the European Commission, commissioned Stahel and Reday-Mulvey to look to see if this trend could be profitably reversed. The resulting report, entitled Jobs for Tomorrow, the Potential for Substituting Manpower for Energy, laid the intellectual groundwork for a circular economy. Yet they didn't use this term. They referred to something called an economy of loops, and later the performance economy. The central idea in the performance economy is that if we measure success based on the quality and quantity of stock of material in an economy, rather than the total sum of industrial output, then a system that both preserved local jobs and the value of manufactured materials could be possible. Now let's wind the clock forward 14 years and turn our gaze from Brussels to Hanover. In 1990, Hanover was awarded the World Expo for 2000. Hosting the expo in the millennial year was viewed as a particular honour for the city, so they commissioned a set of principles that would govern the design of the buildings that would form the expo. American architect William McDonough and chemist Michael Braungart published the 9 Hanover Principles in 1992. These principles, from eliminating waste to designing safe objects of long-term value, set a framework for designing buildings with forethought of their environmental impact. They also provide us with the first framework for addressing circular economy through design. For the next 25 years, McDonough and Braungart continued to develop these principles, relabeled in 2002 under the name Cradle to Cradle, a name that I'm sure many of us are familiar with. At the heart of the C2C approach is the idea that, in McDonough's own words, we need to move from a mindset of doing less bad to doing more good. That through our buildings, we can create a built environment that is both better for people and nature. At the same time that McDonough and Braungart were writing their Hanover Principles, another American architect, this one from the West Coast, was putting the finishing touches to a cult classic in architecture books. How Buildings Learn by Stuart Brand is an exploration of why some buildings get better with time while others get worse. Brand's simple thesis, that simple, flexible and adaptable buildings become loved by their owners and occupants, while complicated, inflexible and inadaptable buildings become loathed. And Brand gives us another way of looking at the whole building life cycle and how buildings change with time. The most valuable tool that comes from this book is the diagram that describes the 6 S's, the 6 shearing layers of a building. These are the elements of a building that change at different speeds over time and need to be kept separate from one another to allow flexibility and changes of use. So more recently, the ideas of these 3 groups of thinkers, among others, have been brought together by the Ellen MacArthur Foundation to form a coherent whole that we now refer to as the circular economy. Each of these groups of thinkers I've mentioned included an architect. Yet the irony is that these ideas have flown faster and further in other sectors, like automotive and industrial design, than they have done in the built environment. So what is a circular economy? I've given the history, but what is it? Getting this right is super important, because in our fight against buzzwordification, being disciplined about definitions is our most powerful weapon. We need to be clear about what is and what isn't part of a circular economy. Let's take it one word at a time, starting with circular. In this sense, I mean circular to mean avoiding waste. The early circular economy thinkers, particularly McDonough and Braungart, were inspired by natural ecosystems where there is no such thing as waste, only nutrients. And so there's a close connection between circular economy and biomimicry. It's important to say that circular economy is about more than waste, but nevertheless, this is a useful starting point. So having established this fact, that circular equals avoiding waste, pretty much everything else we can talk about in circular economy concerns the second word, economy. If we are not going to throw things away, remembering there's no such place as away, only somewhere else, the question arises, how can we get most value from the things we don't need or want anymore? As I see it, there are 4 strategies we can adopt to add value and reduce waste in the built environment. We can use our assets more intensively. We can keep materials in our assets for longer. We can keep the assets themselves for longer. And when we finally don't need those assets anymore, we can deconstruct them rather than demolishing them. To see what those 4 strategies might look like in practice, it's time to grab our hoverboards, jump in the DeLorean, and take a trip into the future to see how circular economy is going to change the prospects of the building we're sitting in, number 8 Fitzroy Street. The most obvious thing to say about this building is that it is an office building. The average European office building is unoccupied or unused 35 to 40% of the time, and that is during office hours. There's clearly an opportunity to make better use of the office spaces we already have. Could Arup, or our landlord, partner with a workspace platform to offer empty desks to startups? Assuming that questions around security could be solved, such an approach would add an additional revenue stream to this building, increasing its value, at negligible extra cost. This is only considering office hours. What about outside office hours? This building is occupied 24/7 by office security. What changes would we need to make to its operation and its architecture to allow it to be made available for uses outside office hours, for example, to community groups? Or could we use it as an event space? How many additional revenue streams could we find for using this building outside office hours? By making more intensive use of this asset, the demand for building new purpose-built venues will diminish, meaning the industry as a whole will use less material, which meets our planetary boundaries objective, while at the same time increasing the value of number 8 itself. All this extra use, however, naturally increases the wear and tear on the building, increasing the need to refurbish, replace, and upgrade the internal fixtures, fittings, and finishes. And when it comes to refurbishing these, we should aim only to replace the components that are worn out or become obsolete, minimizing the amount of new material going into the building. We need new approaches to design and detailing to make sure that this refurbishment process is as cheap and easy as possible. We also need to consider new business models because we want to make sure the value from this refurbishment process lands with the companies best placed to capture it, namely the suppliers of the materials themselves. And new business models is something that I'm going to come on to in a bit of detail a bit later on. Eventually, though, the market conditions of number 8 are going to change. Let's say that in 15 years, we're all working so effectively from home, the demand for offices in central London drops. The demand for housing is still going to be high. Remember those extra 2.4 million people that London has to accommodate. So the market signal becomes to change this building at least partially into apartments. Has such a change of use been considered in the design of this building? I'm not sure it has, but the open plan and generous floor-to-floor heights are certainly a good start. There will be challenges around the facade and the services distribution that the future design team will have to overcome. But let's assume that they do overcome those challenges. This building is successfully transformed into the homes for new Londoners, as well as being offices for Arup. Number 8 survives the changing market and protects the value of the materials in its structure and facade. The market, however, will keep changing. Let's say in a further 15 years, taking us forward to 2047, Camden Council decides to lift the planning height restriction in this area of London. And remember, as we've seen in the past few years, if not the past week, in politics, anything is possible. The growth of this new tall building cluster will be fueled by the arrival of Crossrail 3, aka the Wills and Kate line. The landlord sees an opportunity and decides to go tall on this site. After 40 years long service, number 8's time is up. However, in 2047, circular economy principles are deeply embedded in the industry, so the landlord decides to deconstruct number 8 rather than demolishing it. The facade is taken off and refurbished and reused on a project nearby, being designed by an architect who doesn't mind using a facade clearly with an early noughties aesthetic. While the facade is saved, the structure is not. At the minute, there's no way of deconstructing this sort of concrete. The best we can do is tear it down, crush it up, and use it as fill, effectively destroying 70% of the value of what was previously an expensive, high-energy material. Certainly preferable to putting it in landfill, but possibly a case of could do better. So having secured the most value we could from the doomed number 8, and regretted losing the value in the materials we couldn't save, we apply the lessons we've learnt from its life to its replacement. The new number 8 will be designed using scenario planning to envisage a variety of different uses. This will ensure that the design does not lock in any unrectifiable challenges to future changes of use. Once flexibility has been designed in, materials are selected that are low impact or are reused from other projects. And anything that is likely to wear out or become obsolete is designed to be easy to replace. The building is smart so that its spaces can be shared in time and optimized in space. And the new number 8, while it sounds impressive, will be nothing special, because as I suggested in 2050, all new buildings will be designed like this. Stuart Brand brings us back from that rosy imagined future with a bit of a bump. He said, "All buildings are predictions. All predictions are wrong." A fact that opinion pollsters have been ably demonstrating now for a couple of years. Yet imagining the future in this way, a form of scenario planning, has been very useful in highlighting some of the key ideas in a circular economy. So now that we're back in the present, the question is, what can we do about this? I've got 3 questions I'm going to suggest we can all ask ourselves now on our projects to help us bring a circular economy closer. The first is, how long will your building last? Now, to my knowledge, most building designers are not involved at the end of life of their buildings. It's not something we therefore experience through practice, nor is it something that is taught. Yet, this stage of the building's life, the end, is critical for a circular economy. We need to be able to take our buildings apart, either for refurbishment or deconstruction, as in the number 8 example, in a way that is quick, affordable, and preserves the value of the materials in the building. Different buildings will require different approaches. For some, a long-term view will be appropriate, when we need to design for flexibility, adaptability, and changes of use. For others, a lighter touch approach would be better, designing for reconfiguration, replacement, upgrade, even mobility. In the former, it will be easier to justify bespoke parts due to their long anticipated life. Yet in the latter, standardization, an oft-discussed topic in the built environment, will be needed to help achieve a better flow of materials from one project to the next. As a designer, I find this question really interesting, because for me it raises a bit of a debate of how we view architecture. Is architecture art, seeking novelty, or is architecture optimization, seeking a bespoke solution for a particular client on a particular site? Or is architecture vernacular and the general background to our everyday lives? And the particular example I think of here is the comparison between typical Georgian townhouses and iconic residential towers. The next question we might ask ourselves is, where will our materials come from? We will not find a productive use for second-hand materials if we do not find a way of incorporating them into new projects. For example, in many cases, second-hand steel is just as good as brand new steel. The issue is second-hand steel does not come with the mill certificates, weld inspection records, and other QA documentation that modern engineering specifications ask for. We can respond to this in two ways. We can either develop new ways of testing second-hand steel, so that to prove what we already suspect, which is that if it stood perfectly well in a building for the past 50 years, it's likely it can do it again for the next 50. Or we can rewrite our specifications so to allow the use of tried and tested steel in a new building without the same level of proof required of brand new steel. Again, this sort of question raises important implications for designers. In design, we are accustomed to the freedom afforded to us by abundant materials supplied bespoke to our projects. In a circular economy, this freedom is going to be constrained. Designers will need to learn to work with the materials that are available to them. And I'll be interested to hear your response as to how the design community should respond to this challenge. My third and final question is, who will own your materials? Now, I'm not suggesting in a circular economy that the ownership of assets will change. And as we've seen with the number 8 example, our assets are going to become more valuable as we extract more revenue streams from them and work less hard to keep them at high value for longer. What I am suggesting is, and as I mentioned earlier, we need to adopt new business models. We need to move from a model of buying and selling products to buying and selling services. And this change is going to have 3 impacts. The first is that manufacturers are going to be incentivized to make their products last for longer. For example, Philips' pay-per-lux scheme, where clients pay for light rather than light bulbs. In this example, the longer the lights last, the cheaper it is for Philips to provide the service. The second implication is that manufacturers will retain ownership of their materials, and this means they will be responsible for processing them at the end of life. This makes sense, as manufacturers are best placed to deal with those materials at this stage. They know what went into them in the first place, and they have the facilities needed to extract most value from them through remanufacture. So for example, glass manufacturers gain benefit from increasing the recycled content of the glass that goes into their plate glass float lines. Yet, they can only do this if they know the quality of the recycled glass coming in. If that company owned the glass in a building, they would be responsible for taking it off the building when it wasn't needed anymore. And that would provide them with the controlled and guaranteed supply of waste glass they need. The third implication is that these new business models will move the cost of materials from CapEx to OpEx budgets. And this will promote the sort of long-term, whole-life approach to design and procurement that leads to better outcomes. In some infrastructure projects, this is already achieved through design, build, operate, maintain contracts, where designer and maintainer are the same organization. The designer is incentivized to deliver maximum long-term material value. It's not completely clear to me yet how these 3 changes will impact design. One thought is that the role of the designer will continue to change, will continue to be one of an integrator or coordinator role, rather than the designer and specifier of specific products. And again, I'd be interested to hear your thoughts as to what this might mean. At the start of this talk, I set myself the challenge of explaining the value of adopting a circular economy approach, and of explaining how a circular economy might be made a practical proposition in the built environment. My conclusion is that circular economy is a tool that helps us work within planetary boundaries. As a tool, this should be considered on most, if not all, projects. Yet as a tool, its use should be tailored to the job of work at hand. Circular economy principles are going to be harder to apply on some projects than others. Projects which consider architecture as art or sculpture, or projects which only consider one possible use for a building, are likely to have a harder time extracting the most value from these ideas. Other projects, which consider people first, in a framework that considers the whole life cycle of a building, are likely to fare much better. This tool, circular economy, helps us maximize the residual value of materials in the built environment. This tool helps us future-proof our buildings against future uncertainty. This tool helps us whether we're building a building as an investment or to occupy. And this tool ultimately helps us decouple resource consumption from economic growth. The idea of circular economy as a tool only, though, is maybe a little utilitarian. So I also want to say that circular economy is a source of inspiration. It inspires us to create new designs and new business models that help meet clients' needs in new ways while protecting the value of materials in the building. And I see this positively. And I want to leave you with this one final quote. Circular economy is not about replacing sustainability. If keeping within planetary boundaries is our aim, then circular economy is one of the tools and sources of inspiration that we have to make that aim a reality. Thank you very much for listening. I'll now take questions. Any questions?
Yeah, you made the point about the reuse of concrete in a very simple form with just a granular material. Has there been any more work done in terms of being able to advance the use of it as a byproduct of the demolished building?
My understanding of it is that you can use recycled concrete as an aggregate. That comes with a lot of chemistry challenges for the concrete technologists and has to be approached with a certain degree of caution. Still, you're taking a high-value material like concrete and you're using it to substitute in a relatively low-value and low-embodied energy material like aggregate. So the question is, I know that there are some startups in the Netherlands, for example, that are looking at creating demountable precast concrete systems. So in the continental European market, precast concrete is already a much bigger industry than it is in the UK. And so that industry as a whole is looking to see if they can create deconstructible concrete structures. But I think it's quite early stages.
Richard, inspiring talk, thanks for that. I suppose the question I've got is, what needs to happen to enable this? I mean, what would be the drivers? Do you see it as something that would have to be, for example, taxation, incentivisation, like with renewable energies and so on? I mean, it won't happen on its own, presumably.
I think what has changed relatively recently, say in the past 10 years, is that digital technology and sort of the idea of Internet of Things, smart buildings, really is starting to unlock or reduce the barriers to this. The reason why we've got the system that we've got is that industrial production simplifies an otherwise quite complex world and provides us with this supply of standardized ISO stamped materials that we can rely on. And if we go out and try and take stuff back from the industry, that we lose that simplicity. And I think the idea of sort of material databases for buildings, trying to add the information that we need to know what it is that we're getting back and using digital technology to collect that information is one of the key enablers, I would say, that will help us deal with the complexity and be able to reuse second-hand or third-hand materials with the same sort of confidence that we can use brand new materials with.
I'm interested in the idea of determining the success of a circular economy by the total value of the materials within it rather than the total output. How do you think you go about assigning value to new and reused materials?
That's a good one. So the Stahel's performance economy model, this idea, as you suggest, of changing the system so that we're measuring the value of the stock rather than the throughput, it's kind of the big background picture to circular economy. It does require the entire global economic model that has served us for the past several centuries to sort of turn it around. It's a bit of an oil tanker kind of situation. It takes a while to shift that. At the minute, within the industry, specifically built environment, there are two trains of thought. There's the embodied carbon camp and the embodied energy camp. The infrastructure side, driven by the Green Construction Board, are looking very much at carbon as the metric. and they have a mantra: reduced cost, reduced carbon. If you focus on reducing carbon in your projects, you almost by that process, you reduce the cost. The Treasury has bought into that. HS2 has bought into that. The other big infrastructure and national level providers have bought into that. On the other side, there's sort of an embodied energy type camp, and they would argue that if we were to work within planetary boundaries, which are sort of set at the limits of the biocapacity and energy capacity of the planet, then embodied energy is the purest kind of metric that we could use. So carbon is linked to cost, energy is also can be linked to cost, and there's some academic work looking at the energy cost metric, which is an idea that sort of sadly deceased David Mackay came up with while he was with the government, which is trying to link together an idea of cost and embodied energy into a single number. So I think there are a couple of different ideas, and it'll probably take a while before we settle on one or the other. But I think, yeah, if we were to use those metrics, we'd be able to compare apples with apples in terms of existing materials could come in quite low, new materials would come in quite high, and we might be able to distinguish on that basis.
I think what Richard rightly showed was the variation in opportunities in the industry overall for thinking around the circular economy. It was also really right to talk about buzzwords and actually a call for action. I thought that was really excellent. So aspects of the alloys and metals industry, they're very keen on the idea. He was quite clear about some of the downsides of other material uses. The work on timber is another aspect which I think would come up, and he showed the treat building there as well, which would be great to kind of see. So the industry is actually adjusting to this overall. He's seizing on, I think, a bit of the zeitgeist for the future of the industry overall, and that might also come from kind of a new generation of designers seizing on aspects of culture which actually are very different. So he showed the vinyl there, but actually streaming of services for music player for the new age is all part of their understanding and acceptance. So I think it's going to be great to see how different aspects of the industry culture changes with a new whole generation of designers and clients thinking about circularity as part of an enabling platform for building design, building ownership and asset management. So it's fantastic. I thought it was really, really good.
Absolutely, I think it is. It's the time is right to do that. It's critical that we do that. I think my sense, especially from this event and my colleagues, people I collaborate with, is that we must be doing it and we will be doing it. I guess my question is really around legislation and how we create momentum that means that we have to do it, in much the same way that energy use and legislation around that has been developed in the past 20 years. Really, how do we encourage government to actually legislate for this and make it happen? I think that's critical because whilst the industry is ready, it needs to have that final momentum and push to make sure that it actually happens. Yeah, I mean, there's a question around that, I guess, and I've actually had a client in the past which was Shell, Royal Dutch Shell, and obviously governments are cyclical. It's every 4 years and the policy changes. So there's a challenge around that they're really only interested in 4 years, not in what's going to happen in 2050. So it's happened in the past with energy use and energy efficiency, so it should happen again. But I think it's critical for large organisations within construction to really kind of band together to start to make it happen and to really sort of lead the way in that and set by example. So for instance, a company like Shell, obviously key in the kind of energy environments, partners with big industrials to actually create policy to drive things forward.